culprit.
Okay, so first and foremost here with our graph, what you're going to have today is I believe you have 6 problems. 6 problems total. That's your whole entire assignment. And the goal is to try to graph with everything we have up until this point. Like figure out where x-intercepts are if possible, figure out y-intercepts if possible, try to figure out where the highest and lowest point is. Now, obviously, if it's a quadratic, we have means of finding like where the highest and lowest point is, the min or max, the critical point. I want you to try to use the differential quotient today. I want you to try to like get used to that formula. We're gonna do one today. I'll just kind of pick an easier one. If we need another one, I'll pick another one. That way you get like some practice on like what we need to do here. So let's do an example. I'm just gonna kind of make up something here if you're okay with that. 3x squared plus 4x plus 1. I don't know if we've done a problem like this before.
Yeah, we know.
Have we done that problem?
Close.
No.
Nice.
Let me know if we have.
Yeah, that might be.
No.
We did yesterday.
Is it?
Maybe.
No, we did 2x plus 4x plus 2.
Okay, we were fine. We're on a different one.
This is our
Okay, it's different. Okay, we're good.
I don't respond.
Okay, so here's the idea. So this is what they're going to give you. It's a function. They might even have it labeled as f of x. All right. So here's what I want you to do. We need to graph with everything we know as of this moment. I don't know if we did this exact problem, but it was probably something close.
We're getting 2x squared plus 4 plus 2.
Okay, good. So it is different. All
Plus
right.
4x.
So here's the idea. So since it's a quadratic, we can find a y-intercept. We do know we can find x-intercepts if it's factorable, or you could at least do like quadratic formula to figure out where the
If it's
x-intercepts
not
are.
factorable.
It is not factorable. And then we at least know where the end behavior goes. These are things that we're kind of piecing all together, right? We can figure out if it's
They're both
symmetric,
going up.
turning points, they're both going up, they're because it's positive, something like this. All right, now, we get the idea of like where it's going. Now, we're gonna fill in little details. The goal is to figure out that perfect turning point. We gotta put it all together. Now, at any point, let's say that your graph goes off, like it's off the grid, where it's like the low point is too low. Just kind of put a number, like put a dot below the graph and just kind of write down the coordinate where it should have hit. Or maybe it's above the graph. I try to pick numbers that they should be somewhat smaller. You never know when you start actually doing the math, it could be way off the chart and I didn't predict it. So 3x squared plus 4x plus 1. So y-intercept. We've got a y-intercept of 1, right? You plugged in a bunch of zeros. X-intercept, we can factor this thing apart. It is factorable. It's a trinomial. It's plus plus. 1 and 1, 3x and 1x. That will make the 4 in the middle if you FOIL it all out. So what are my x-intercepts?
Negative 1/3.
Negative 1/3. Negative 1. So okay, so negative 1/3 and negative 1. So they're really close together in my positive y-axis numbers here. So it's probably doing something like this. It's turning around, kind of going up. The problem is, as you can tell, I have no idea where that low point is. Like where that x actually is, that would give me the lowest point. All right, it's gonna be a decimal. You can pretty much see it, that it's at a weird spot, that turning point, when I went from decreasing to increasing in terms of a continuous function. So to figure that out, that's where the differential quotient comes into play. That's this formula. So differential quotient. That's where it's f of x plus h minus f of x all over h. I want you to use this formula where the limit as h approaches 0. We want h to eventually go to 0, where h is that difference in measurement, where we go closer and closer together, where it literally pinches where the low point or high point is on a graph. This graph has a minimum. So we should be able to hopefully go find that decimal or number where it is. If it's a decimal, go 2 or 3 decimal places. That's all I want you to do today. Does that make sense? If you get like a clean fraction, like let's say it's a third, just write a third. I'm fine with that. But 2 or 3 decimal places, don't go more than that. That's a waste of your time. Okay, let's go into this formula. So to do this formula for your problem, and again, I think the highest power I go to for you guys today is the power of 3, a cubic function. So you get kind of a sense for how to do this. I didn't go higher than that. The book had like crazy numbers. I'm not going to make you do that. because they expect you to use like Pascal's triangle and stuff. We haven't reviewed that for a while, so I thought we better avoid it. So x plus h, that's that function with all the x's taking out and x plus h plugged in all their spots, right? That's this part right here. I'm going to try to color code. Then we're going to subtract. We're going to subtract the original f of x, this part. The original f of x is 3x squared plus 4x plus 1. And what's on the bottom? H. H is, you always divide by h. Does that make sense what we're setting up? The setup is actually the hard part. Most people struggle like how to set that part up. I give you plenty of space on the side. You should be able to handle that. Just because all that stuff that we did over there, like you guys know how to do that really quick, like in your head. Maybe the factoring part you have to write down, but most people can do like the little stuff, so you have plenty of room to actually do differential quotients. If you need a separate sheet of paper, just staple it to it. But this part here, inside the parentheses, this is where I'm plugging the x plus h. All right, so now, this is the part where I need to do a ton of math here. I need to FOIL this together. There's actually two parentheses. Don't distribute power of 2. We have to FOIL. Once I have that FOIL done, then I can distribute 3 over it. You have to FOIL first. I'm going to do it in my head. I'll write it down here. And as I do it, I am going to distribute power of 3 as I go through it. So what we should get is 3x squared plus 6xh plus 3h squared. That's FOILing it and distributing the power of 3 through it. Distributing the power of 4, I get 4x plus 4h plus 1, right? That's that part back there. And then I'm going to subtract the back where I distribute the negative sign. And that's all over h. And again, this is as the limit as h eventually is going to approach 0. I want to get as close to that low point as possible. Questions with the setup? Now, how do we know if we're doing it right? What happens in this? Yeah, a bunch of things cancel, right? Things that don't have h's. That should happen if you do this right. 3x squares, 4x's, 1's, those are gone, okay? So those are all out of that problem. And so now what I'm left with are these 3 items, okay? And so once we're down to this part, right? 6xh plus 3h squared plus 4h. We're going to divide everything by h. And once you divide by h, then the last thing to do is to make sure that you put 0 in for h's. Because I want h to eventually turn out to be 0. Right now I can't plug it in because I can't divide by 0. That's why I'm waiting. So dividing this out, here's what I'm left with. I'm left with 6x plus 3h plus 4. Does that make sense when I divide everything by h? Now, when I plug in a 0 for h, what happens?
0.
Yeah, this part literally drops out. It literally turns into 0. That way it's squeezing it to right where the middle is, right where that lowest point of my graph is. So what you're looking at here, the slope of this graph, the slope that's constantly changing, is represented by 6x plus 4. That's the part I needed to find. That's what the differential quotient spits out. Now, why that's important? This will help me find the peak and valley. The peak and valley is literally made from that slope, where slope would be 0. That's where the bottom of that graph would hit. This slope would literally be a horizontal line. So I'm going to take that graph, plug in a 0 for 6x plus 4, because that's my slope. I'm going to set 0 equal to that, and then solve. Subtract that over, and divide by 6. There's the x coordinate where my lowest point hits. That's the x number. You're kind of seeing it on my graph. I try to be as close as possible to it. So it's negative 2/3. And then to find the y number where it hits, the lowest point, that turning point, is I have to take that number, which is basically negative 0.6, negative 0.66, if you go 2 or 3 different places, and plug it in there, and it'll spit out where the y number is. So now, if you want to be exact, you can do that. If you just want to give me a decimal, I'm fine with that, as long as you're in the ballpark. So, I'll give you guys the option. Do you want an exact answer, or do you want just something that's close?
Exact.
Close? Okay, I'm going to go close. That's the first one I heard. So, So if I just type in the 0.66, negative 0.66, okay, I'll go 3 decimal places, let's say, just close, right? So negative 0.66, square it. So if I square that, it's going to turn it to be positive 0.443556. I'm going to take that times 3. So this number turns out to be 1.3. I'm going to add that to 4 times the negative 0.6. So 4 times the negative 0.666. I get a negative 2.664 here. So I'm adding these two together, so it's a negative number, and then I add 1 to it.
What negative one?
So this is positive, that's negative, that was positive. If I add them up, my x number that I'm getting is negative 1/3. It's negative 0.3 repeating. That's the what's given out.
So what's
That doesn't.
what's exactly?
So it's 1/3. It's 2/3 over, 1/3 down. That's where it's hit. 2/3 over, 1/3 down.
How do you find the
So
exact?
you just plug.
The exact, if you want it, the exact number, you take that fraction I just found, and you plug the fraction into that 3x squared, 4x, you plug the fraction and you simplify what the answer is. It ends up being 1/3, negative 1/3.
So can we just type that in the calculator?
Yeah, just type it in the calculator. That's all you have to do, just type in some decimals. You can literally just do 2 or 3 decimal places, don't go more than that, and then just write down your final answer.
Why didn't you just use a fraction?
You could use a fraction. If you want to just type in the fraction,
That'd be
hit
easy.
enter.
that's
Do
what I
that.
did.
That's fine. And it gives you 1/3, right?
Yeah.
Yeah. So, I mean, it just, if you're in the ballpark, I pretty much give it to you. I just want to know roughly where that turnaround is.
So,
What was that?
I think you chose a way, it was like the same opposite always positive.
That's cubic roots. That's cubic roots. I think yesterday we did one where we did a vertex, where we did something like completely square process. We did that one yesterday. Okay, questions on this? Now again, I do want you to find that low point to kind of estimate where that dip is, because the idea is that we don't know where it's at. Now, it could turn out where it doesn't have them. Maybe this is so complicated, maybe it's like a quadratic, and you can't set it equal to 0 like I did and just solve. Maybe there isn't any. Like you do a quadratic formula, or you can't factor it, because this can happen if you have a cubic function. It could be a square here, and you can't solve. It's like a negative. So that means there's probably is no low point. That happened. I think that was the example I did yesterday. It didn't even have an actual like critical point. It didn't have a high point or a low point on my graph. Questions at all about what we're doing? You have 6 problems today. That's it. Hopefully you have notes from yesterday. I basically just picked 6 problems, and I tried to pick kind of easier ones from the book,
You're like this?
like this.
That's what you said last time.
So I know. So I avoided the book because the book can be.
We all
Yeah,
know how that goes.
that was a disaster for you guys.
It was surely backwards.
What was?
The last homework we did, it was
Oh, yeah,
curvy
that
backwards.
one.